All right, so here for section 1.4, we're going to talk about operations with functions, specifically adding, subtracting, multiplying, dividing, and composing functions. So first, let's talk about the easy stuff, adding, subtracting, multiplying, and dividing. So if we see something like this, this means g plus m of 7 written like this is the same as saying what is g of 7 plus m of 7. And so if we look at our table here, when t is 7, g is 7. And when t is 7, m is 6. So we just add those, and my answer would be 13. So this would be the same as m of 3 minus g of 3. And so when t is 3, m is 9. When t is 3, g is 8. And so this time we're subtracting, so my answer would be 1. And then here, this is the same as saying g of 1 times m of 1. So when t is 1, g is 9. And when t is 1, m is 0. 9 times 0 is 0. So g times m of 1 would be 0. And so this last one would be the same as saying m of 9 divided by g of 9. So when t is 9, m is 5. When t is 9, g is 3. They ask you for your answers to 3 decimal places. So if you do 5 divided by 3 in your calculator, you'll get 1.6 repeating. So then over here to 3 decimal places, you would say 1.667. Now, hopefully you notice that the next 2 examples that I do are just this exact same thing. So here, if I see g plus k of negative 8, that is g of negative 8 plus k of negative 8. So first we need to figure out what is g of negative 8. So that would be negative 5 times negative 8 plus 5, which would be 45. Right? Negative 5 times negative 8 is 40, plus 5 is 45. Then we need to figure out what is k of negative 8. So that would be 8 times negative 8 squared plus 7 times negative 8 minus 9. I'm going to do that in the calculator because I just think that it makes more sense that way. Plus 7 times negative 8 minus 9. 447. So, and then I want to add these. So I would get 492. Okay. So if I wanted to do k of negative 6, really? Okay. Minus g of negative 6. First I need to figure out what k of negative 6 is, so I'm not going to write that all out again. I'm just going to go, okay, 8 times negative 6 squared plus 7 times negative 6 minus 9, 237. And then g of negative 6, negative 5 times negative 6 plus 5, that's 35. And this time I was subtracting. So 237 minus 35 will be 202. and then g of 0 times k of 0. Well, if I plug 0 into g, this -5 times 0 will become 0, so I'll be left with just this 5. If I plug 0 into k, this will be 0, this will be 0, and I'll be left with this -9. And then we're multiplying on this one. We'll have -45. And then k of 3 divided by g of 3. 8 times 3 squared minus 7 times 3 minus 9. So that's 42. And then -5 times 3 plus 5. Oh, that was plus 7 times 3. I knew I did that one wrong. Okay, plus 7 times 3. 84. You know, I think I might have done minus. Let me check this one. No, I did that one right. Okay. So then 84 divided by -10 is going to be -8.4. So this one and the one above it, basically the same thing. It's just using function notation versus using a table. And then we're going to do one more just like that, only using a graph. So if we're using a graph here, then we would say, okay, well, P of 5 plus F of 5. Here's P. When X is 5, Y is 2. When F is 5, Y is 1. So adding them would be 3. F of 2 minus P of 2. So on F, when X is 2, Y is 5. On P, when X is 2, Y is 0. And we were subtracting that time, so 5 minus 0 is 5. On the next one, P of 3 times F of 3. Well, P of 3 is 5. F of 3 is 2. And so this time we were multiplying. And then on this last one, let's see, F of 0 is 0. P of 0 is 3. And so 0 divided by anything is just 0. Okay. All right, so the other thing that we're doing with these functions is composing them. So composing functions is when you evaluate functions at functions. Here's what I mean by that. Here we have k of h of t. So if we look back at the second example on the other page, when I was trying to find g of -8, I replaced the t with -8. When I'm trying to find k of h of t, I'm going to replace the t with h of t. So if k is 3t plus 5, and I was evaluating it at a number. Like if I was asking you what is k of 10, you would say 3 times 10 plus 5. Well, if I say to you, what is a k of this, you would say that it is 3 times this plus 5. And then we would just distribute. So 3 times 3t squared is 9t squared. 3 times 2t is 6t. And then we would add the 5. Okay. So here, if we want to do m of h when we're composing at a value, do the inside first. So first I need to know what is h of 2. So to find h of 2, I plug a 2 in here. 3 times 2 squared plus 2 times 2. So that's going to be 4 times 3 is 12, and then plus 4, so 16. So if h of 2 is 16, then that means I can replace this h of 2 with a 16 and make this m of 16. And so then m of 16 is the square root of 3 times 16 plus 3, which would be 48 plus 3. Now they do want a decimal, so the square root of 51, the square root of 51, 7.141. And so then h of k of 1, so again, we're going to look at the inside first. K of 1 would be 3 times 1 plus 5, which means that k of 1 is 8. And since I know that k of 1 is 8, I can take this k of 1 and replace it with an 8. Which means that what I'm actually looking for here is h of 8, which would be 3 times 8 squared plus 2 times 8. Which is 208. Okay. Excuse me. Let's practice a few more like that, only here we'll make sure that we can do it with the table and the graph as well. So if we have g of f of 1, the first thing I need is f of 1. So f is the table, and when u is 1, f of u is 0. So if I know that f of u is 0, or f of 1, excuse me, is 0, then I can replace this f of 1 with a 0. And that means what I'm really looking for here is g of 0. So if I go on my graph at 0, g of 0 is 1. How about q of f of 3? Well, again, I'm going to start on the inside here. So f of 3 is 1. So then I'm going to replace this f of 3 with a 1. And so now I would say that that is 5 times 1 over negative 7 times 1 squared minus 5. 5 times 1 is 5. Negative 7 times 1 squared is negative 7. Minus 5 would be negative 12. Again, it's going to want a decimal. So I would say negative 0.417. F of g of 3. So first we need g of 3. G was the graph. So at 3, your output is 2. That means now I need f of 2, which is 5. And then last but not least, I need q of g of 1. Okay, so first I need g of 1, which is 4. And then I need q of 4. So that's going to be 5 times 4 over negative 7 times 4 squared minus 5. Well, I know 5 times 4 is 20. But again, they're going to want a decimal. So let's say negative 0.171. Okay. So for this last one, we're going to find the composition or find what's happening here, and then we're going to look for the domain of that. So for example, if I have g over q, I would have 1 over the square root of t over t squared minus 9. Now, I feel like your instinct is going to be to get rid of your complex fraction because you've been told, like, in every math class that you've ever taken that talks about fractions, that you can't have a complex fraction. But guess what? I don't want you to get rid of the complex fraction. I want you to leave it, because we need to think about the domain of this function, and the domain is important of it. The domain of it is important as it sits right now. So we need to think about our rules for both square roots and rationals. When we have a square root, we say our radicand is greater than or equal to 0. When we have a rational, we say our denominator, we say that our domain is anything except what would make our denominator 0. So the first thing I notice is I have this t squared minus 9 in a denominator. That means that t cannot be 3 and t cannot be negative 3, because if I put in a 3 or a negative 3 here, it would make this denominator 0. So I'm going to start by saying, okay, t is definitely not 3 and it's definitely not negative 3. Now I'm going to look at this fraction. Okay, the t in the denominator means that t can't be 0 because the square root of 0 is 0, and then I would have 0 in the denominator of that fraction. The next thing I'm going to say is, okay, well, my radicand, which here is just a t, has to be greater than or equal to 0, because that's what I do with the square roots. So now I'm going to look at everything I have here, and I'm going to put a domain together based on all of this. Okay? So I'm going to look at this first and say, okay, t definitely has to be greater than or equal to 0, except it's not 0, and it's not 3. I didn't repeat that -3 because -3 is not greater than or equal to 0. So this eliminates the -3. So then what we're looking at here is saying, okay, well, it is greater than 0 because this says equal to, but this says not equal to. So I'm going to say not equal to. So greater than 0, but it can't be 3. So not 3. Or any number greater than 3. And this satisfies all of these conditions. Now, I want you to know that I'm not super happy about this middle part being on here because there's going to be a point later on in the semester where we talk about inequalities with quadratics. And so since you don't know that, I feel like maybe we don't have all of the skills that we need to do this one. So I'm just going to show you a shortcut. So if we had g of q of t, that would be 1 over the square root of t squared minus 9. Okay, so first of all, I'm going to go back to t can't be 3 and it can't be -3 because either one of those would make the denominator 0, right? And so now the other piece of this would be where is t squared greater than, or t squared minus 9, excuse me, greater than 0. I didn't say greater than or equal to this time because we know it can't be equal to 0 since it's in the denominator. But since we don't know exactly like a strategy to solve these yet, I just want to talk to you about it. So if we think about where is this greater than 0, well, what if we plugged in numbers? Try 1. 1 squared is 1, minus 9 is -8, not greater than 0. How about 2? 2 squared is 4, minus 9 is -5, not greater than 0. We've already said we can't do 3, but what happens if I plug in 4? 4 squared is 16, minus 9 is finally greater than 0. So what's going to happen here is that this is going to work for any value greater than 3. I don't know why this pencil's being so annoying tonight. Or less than -3. And my hint is that that's how it's always going to work. So if this was t squared minus 16, this would be greater than 4 or less than 4. If this was t squared minus 81, this would be greater than 9, less than 9. If this was t squared minus 144, this would be 12 and 12. Okay? So then my domain for this middle one is -∞ to -3. And 3 to infinity. Okay. So then for q of g of 0, we would say, or of t, excuse me, we would say q, so we would say 1 over the square root of t squared minus 9. And again, I know that your gut is telling you, ooh, square this, but I don't want you to do that. I want you to stop and say, what is the domain of this as it sits? Okay? Because here I have this radical, which means t has to be greater than or equal to 0, but it's in the denominator, so t can't be 0. So the domain of this would be t is greater than 0. which would be 0 to infinity. So the problem is that if you squared this and you made it 1 over t, you would say that the only thing you can't plug in is 0, but you can't plug in negative numbers because the square root is still there. Just because we wound up squaring it doesn't mean that that original function didn't have a square root anymore. Okay, so my advice to you is don't reduce, don't do anything, don't make any changes. Find the composition, keep it as it is, and then find the domain of the thing that you're looking at. Now, I do have a quick note for you about these questions, and that is that I remember the first time I taught this class with Andy's material, I felt like I didn't think that he did a super thorough job explaining these. So what I did was I made my own example video just for this problem. So this is going to be the only place this whole semester where if you look, you'll see that you have the option for a help video. It's the same video, so you have 2 of these problems, and it's this on your homework, and it's the same video on both problems. Like this video and this video are not different, but it's there for both of them, and I go through and I explain it one more time. Okay? Because that's my least favorite problem of this homework assignment. All right. That's 1.4. So now let's talk about 1.5. So 1.5 talks about your transformation rules. So I want to just review them. Now, Andy does a great job talking about transformation rules in his video, but I want to do like a 3-minute down and dirty review and say, okay, see this A? So A tells us vertical and horizontal stretches and shrinks or reflections. So if A is greater than 1, we have a vertical stretch. If A is in between 0 and 1, we have a vertical shrink. And now I put absolute value signs here because if A is negative, we reflect over X. So for example, if A was -2, I would both reflect over the X and stretch by a factor of 2. Okay? And then H tells us horizontal movement. A plus H shifts left, and a minus H shifts right. K tells us about vertical movement. A plus K shifts up, and a minus K shifts down. This is just about all of the transformation rules you will need. So if you have your camera and you want to take a quick picture of this, that might be helpful. I'll leave it up there for a 10 count. That way you can do that if you'd like. Seven, 8, 9, 10. Okay, if you need it back when I'm done with notes, let me know. I'll put it back for you. But for now, so if this is my original function, f, and this is what happened to f after a transformation, what I want to know is what changed. Did my x's change or did my y's change? Well, here clearly my x's changed. My y's are the same, but my x's all moved to the left one. See it? They all moved to the left one. And so a shift left one would be inside the parentheses and a plus 1. Okay. So again, if we go back to my original f and we compare that one to h, well, this time my x values are all the same, but my y values are all different. It looks like they're all one less. So we this time shifted down 1. And so that means that we have a k, a vertical shift. And so I would say down 1 would be a -1 on the outside of the parentheses. So anything on the inside of the parentheses affects the graph horizontally, and anything on the outside of parentheses, or if there are no parentheses, affects the graph vertically. Okay? So having said that, since this +6 is outside of parentheses, that means that it would add 6 to all the y values. Now, had it been something like this, that would affect it horizontally. And remember, the inside does the opposite. So this would actually subtract 6 from all the x values. Okay. So then here, a +4 on the inside would shift the graph horizontally because the inside of parentheses is a horizontal shift. And a +4 outside of parentheses would shift the graph vertically. It is a vertical shift outside of parentheses. So again, anything that's on the outside is going to affect your y's. Anything that's on the inside is going to affect your x's. So see how this 5 is on the outside and it's being multiplied? So that would be a vertical stretch by 5, which means we would multiply your y values by 5. Now the 10 is on the inside and it's being added. So the reason why this was a stretch is because it's being multiplied. Since the 10 is being added, it's a shift. And a +10 shifts left 10. And so then what that would do would be to subtract 10 from all of your x values. Why did I say x and write y? And the 17 on the outside being added would be a vertical shift up by 17. And so then that would add 17 to your y values. Okay. I'm not a fan of this next question. I want you to know that. This is Andy's class. I'm just teaching it. So, but I do want you to know that you will see a question almost exactly like this on both your Module 1 test and on your final exam. So this would be a great place to be paying very close attention. All right. So when you're dealing with the numbers on the inside of the parentheses, because of the way that the horizontal shifts happen, you need to do not just the opposite operations, but also in the opposite order. So here's what I mean by that. If you see negative 7.6x minus 6.6, and I tell you that x is 4, your gut is to multiply 4 by negative 7.6 and then subtract 6.6. And I am here to tell you with the transformations, you want to do the opposite operations and in the opposite order. So instead of multiply and subtract, you are going to add and then divide. So I'm going to take this 4 and I'm going to add the 6.6. And then I'm going to take that number and divide by the negative 7.6. We'll say that's 2 decimal places, so negative 1.39. And that is what is going to be my new x value. Now that rule only applies to the stuff on the inside of the parentheses. On the outside of the parentheses, you do exactly what you want to do. Meaning, if I tell you that this 2 is on the outside, you're going to want to multiply it by negative 7.7 and then add 11.1. And that is exactly what you should do. Multiply by negative 7.7 and then add 11.1. 15 minus 11 is 4. 3. And so on the outside, you would have a negative 4.3. Okay. So again, for the inside, you take the number they give you and do the opposite operations in the opposite order. Okay. All right. So last but not least here, if we have y equals x squared and we want to shift it up 56 and 59 to the right, well, a right shift would happen inside of the parentheses, and it would be a subtraction. Minus 59 would be a right shift. And then a shift up 56 would be a plus 56 on the outside. My note for you is that you need to include this function notation in your answer. If you do not include the g of x equals, when you type it into this box right here, you will not get credit. Okay, so make sure you include that g of x.